It's told in the problem. Now imagine this, imagine this. There is a circular stadium like this, okay? And there are beams which are erected like this. There are beams which are erected all around the circular stadium. Now try to understand this part. There are beams which are erected all around the circular stadium. Now what is told in the problem is, suppose there are 20 pillars of the same height have been erected along the boundary of the circular stadium, which means number of pillars n is equal to how much? 20. If the top of each pillar has been connected by beams, with the top of all of its non-adjacent pillars, to this particular pillar, adjacent pillar is this one and this one. Apart from that, it is being connected with the beams of all the non-adjacent, to the non-adjacent pillars like this, to the non-adjacent pillars like this. So it is as good as considering the diagonal, right? It is as good as considering the diagonal. Now the question is asking you to calculate then the total number of beams. Number of beams is as equal to, is as good as writing number of diagonals in a 20-sided polygon, correct or not? In a 20-sided polygon. What is the formula for number of sides in an n-sided polygon? For each diagonal you have to connect 2 beams, minus you cannot consider all the sides of the polygon, right? Minus n. So the answer to the question will be 20C2 minus 20, which is 20 into 19. This is an easy question if you can reason this out properly. Non-adjacent beams, if you connect, that becomes the side, right? All the non-adjacent sides if you connect, then it becomes a diagonal. If you connect to the adjacent side, it becomes the sides of the polygon. So what is the answer that we get to? 190 minus 20. So answer to the question will be equal to 170, which is the answer to the question.